Space might look still and silent, but it's not. Right now, this very second, the Milky Way, our home galaxy, is hurtling through the universe at around 2 million kilometers per hour. And we are not alone. Thousands of galaxies around us are moving too, all flowing toward the same mysterious point in space. But here is the strange part. No one can clearly see what's there. Scientists call it the Great Attractor, a gravitational anomaly so massive, so powerful, it's dragging entire regions of the universe toward it. It's bending the paths of galaxy clusters, warping the large-scale structure of space itself, and yet, it's hidden behind the thick wall of cosmic dust and stars. We know it's out there because we can feel it, in the way galaxies move. But trying to study it is like trying to find a lighthouse in a hurricane, blindfolded. So what is it? A cluster of unseen galaxies? A superstructure made of dark matter? Or something we haven't even discovered yet? Today we are diving deep into one of the biggest and most haunting mysteries of modern astronomy. What exactly is pulling the Milky Way, and where is it taking us? The story of the Great Attractor begins in the late 70s and early 80s, when astronomers were studying the large-scale motion of galaxies. Using radio telescopes and redshift surveys, scientists mapped the positions and speeds of thousands of galaxies around the Milky Way. And what they found was strange. Instead of moving randomly, as you might expect in an expanding universe, the galaxies showed a clear directional flow. The Milky Way, the local group of galaxies, the Virgo cluster, huge areas of space were all drifting toward a single region near the constellations Centaurus and Norma. This wasn't just a local movement either. The pull seemed to extend across hundreds of millions of light years. The sheer scale of it shocked astronomers. There had to be something massive, really massive, creating a gravitational well deep enough to drag entire galaxy clusters toward it. But when scientists pointed their telescopes at the suspected location, they found almost nothing. The problem wasn't that the Great Attractor didn't exist. It was that it sat behind the thick disk of the Milky Way, an area known as the Zone of Avoidance. Dust, gas, and stars block most visible light from passing through, leaving a blank spot in our maps of the universe. So instead of seeing the Great Attractor directly, scientists had to piece together its existence by studying how everything else around it was moving, like seeing ripples in water and knowing something huge had just splashed in. But what exactly was hiding there? That's where the mystery deepens. And if this already has you questioning what else might be hiding out there, make sure to hit that like button and subscribe. Perhaps we will answer some of your questions in the future. We are just getting started, and the universe is only getting stranger from here. Even though the Great Attractor remains hidden behind a curtain of dust and stars, scientists have managed to piece together some of its secrets. We know it's located about 150 to 250 million light-years away in the direction of the constellations Centaurus and Norma. It's part of a vast network of galaxy clusters and superclusters that make up the large-scale structure of the universe. A kind of a cosmic web with galaxies strung along filaments and threads, converging at dense intersections. The Great Attractor seems to sit within the heart of something even bigger, the Laniakea Supercluster. Laniakea itself contains more than 100,000 galaxies, including our Milky Way, all bound together by gravity, flowing along invisible currents towards gravitational sinks like the Great Attractor. But here is the truly mind-bending part. Even though it's powerful enough to pull entire regions of space toward it, the Great Attractor isn't a singular object. It's not a black hole, it's not one galaxy or even one cluster. It's likely a massive concentration of galaxies, dark matter and hot gas, a gravitational heavyweight hidden just beyond our lines of sight. Further studies have suggested that the Great Attractor might just be a stepping stone towards something even larger, the Shapley Supercluster, an even more massive structure further out that could be contributing to this enormous cosmic tug-of-war. In other words, the Great Attractor might not be the final destination. It might just be one link in an endless chain of cosmic giants, and we are still trying to map them all. As massive and influential as the Great Attractor is, you would think we would have a clear view of it by now. But the truth is, studying it is like trying to read a book through a brick wall. The Great Attractor lies behind what's known as the Zone of Avoidance, a part of the sky that's heavily obstructed by thick dust, gas, and stars of the Milky Way's galactic plane. About 20% of the extragalactic sky is hidden behind this veil, making direct observations incredibly difficult. In visible light, this region looks cluttered, chaotic, and packed. Light from galaxies beyond the Milky Way gets scattered, absorbed, or completely blocked before it even reaches our telescopes. To get around this cosmic blindfold, astronomers had to get creative. They use radio waves, infrared light, and even X-rays to peer into the zone of avoidance. Radio surveys like those from Parkes Observatory in Australia and infrared scans from satellites like IRAS helped map out hints of hidden galaxy clusters lurking behind the Milky Way. Still, the data is patchy. What we are seeing is more like the faint outline of a mountain range through thick fog, enough to know something massive is there, but not enough to fully map its shape or size. This lack of clarity keeps the Great Attractor shrouded in mystery, and it leaves open the possibility that what's hiding there might be even stranger than we expect. The question that's haunted astronomers for decades is simple. What exactly is the Great Attractor? The leading theory is that it's a massive concentration of galaxies, gas, and dark matter. Essentially, it's a crowded intersection in the cosmic web, a gravitational hotspot where several galaxy clusters are piled together, hidden behind the Milky Way's dust. The immense combined mass of these galaxies, along with the invisible pull of dark matter, could easily explain the gravitational pull we are feeling across hundreds of millions of light years. But some studies suggest that the Great Attractor alone doesn't fully account for the velocities we observe. In fact, many scientists believe it's only a part of the picture. Beyond the Great Attractor lies the Shapley Supercluster, a truly colossal collection of galaxies and mass that may be exerting an even stronger gravitational influence on the Milky Way and its neighbors. In this view, the Great Attractor isn't a single, isolated object. It's more like a gravitational stepping stone, a signpost pointing toward even larger, deeper gravitational wells further out in space. There have even been fringe theories over the years proposing that something exotic like undiscovered forms of matter or vast structures built by civilizations far older than ours could be contributing to the pull. But so far, the evidence points to nature doing what it does best: building colossal structures out of galaxies, gas, and dark matter on unimaginable scales. Still, the fact that we can't see it clearly leaves the door open, and the mystery alive. Hearing that an invisible gravitational monster is pulling our entire galaxy across space sounds terrifying. But before you start packing your bags for Mars, here is the truth. The Great Attractor isn't dangerous to us, at least not in any way that matters to human timescales. The gravitational pull from the Great Attractor, while massive on cosmic scales, acts over hundreds of millions of light years. It's like being caught in a slow, gentle current across an ocean so vast you barely even notice you moving. Our solar system, our galaxy, and thousands of neighboring galaxies are all drifting toward this region at incredible speeds. But the key is, the distances involved are even more incredible. Nothing dramatic is going to happen next week, next year, or even next million years. The universe is always in motion. Galaxies collide, clusters merge, and cosmic structures shift over billions of years. The Great Attractor is part of that slow, graceful dance, not a cataclysmic force racing towards us. Eventually, our Milky Way will likely merge with other galaxies as it journeys toward the Great Attractor and beyond. But this process is a natural part of the universe's evolution, not a sudden disaster. In the grand story of the cosmos, the Great Attractor isn't the villain. It's just another chapter, a powerful, invisible current pulling us forward in the unknown. And if anything, it reminds us, even on a cosmic scale, we are all connected by forces we can barely see and barely understand. The Great Attractor is one of those cosmic mysteries that reminds us how much we still don't know. Despite all our technology, all our telescopes, and all of our theories, there are still massive forces shaping the universe that we can barely glimpse. We know it's there because we can feel its pull. We see the ripple effects in motion of galaxies, the subtle gravitational signatures written across the stars. But what lies behind the veil, the full scale of the Great Attractor, its true shape, and its deeper connections, remains hidden, just out of reach. And that's what makes it beautiful. The universe is not a solved puzzle. It's an endless frontier full of secrets that pull at our curiosity just as strongly as the Great Attractor pulls at our galaxy. With new telescopes like the James Webb Space Telescope, advanced surveys, and future deep space missions, we may one day lift the curtain and finally see what's pulling us through the cosmic dark. Until then, the Great Attractor stands as a reminder. The more we learn about the universe, the stranger, more connected, and more wondrous it turns out to be. Thank you for watching. Keep looking up.